Hi guys, today we're going to do simplifying radicals, the second day of it. So we're going to throw some variables into this lesson. So we always want to start with our list of perfect squares. So one more time, it's every number times itself. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. These are math teacher skills. We know a list of perfect squares. So we probably won't need that large, but I always like to go up to 15 squared. Perfect square variables, if you remember what I said yesterday, they're any exponents that are even. So today we're going to have to break down some variables. So we're going to break them down to perfect square other factor, just like we did with the numbers. So let's recall what we did yesterday. Yesterday we just had numbers, so we're going to break these down. Perfect square other factor. So 63. What's the largest perfect square that can divide into it? Good. 9 and 7. So the square root of 9 is 3. Radical 7. You do the next one. What's the largest perfect square that can go into 80? I think we did that one yesterday. Check to make sure you're getting that answer. 108. Check to make sure you're getting this answer. Show your work, please. Sorry, that's hard to read. Same thing with 125. All right, so the negative 1/4 times 32 is negative 1/4. The square root of 16, the square root of 2. This becomes negative 1/4 times 4, radical 2. So we get negative radical 2. 64, 8 to the 6. Do you agree that 64 is a perfect square? It's on the list. Good. 8 to the 6 is an even exponent. So this is a perfect square already. All we do is take the square root. So it's 8. We take the exponent, we divide by 2. A cubed. So that starts the new stuff. Negative radical 121 y to the 10th are perfect squares. The square root of 121 is 11. The square root of y to the 10th is y to the 5th. There's a negative out front, it's real small. So negative 11 y to the 5th. Now we're going to get to y cubed. Anytime I have an odd number, I break it down to the next lower even and then the other factor. So there'll always be a single one hanging out. So we're breaking y squared down, y cubed down to y squared and then a y. So we get this lovely y, radical y. So perfect square, 49, y to the second, other factor, y. We get 7y, radical y. Negative 2, we have even exponents. So because they're both even, we have to break down the 18 to 9 and 2. X squared, y to the 4th are perfect squares. So we break this to negative 2 times 3xy squared, radical 2, which is negative 6xy squared, radical 2. 36, x to the 7th y squared. So 36x to the 6th y squared. There's one x left over. So it becomes 6x to the 3rd y, radical x. A squared b cubed. How do you break that one down? Good. The even exponents are a squared b squared. What's left? A radical b. So we have ab radical b. 2 more. Break this down to perfect square, other factor, so try it. Did you get 4abc, radical abc? Nice job. And lastly, b to the 4th is the perfect square, a is the other factor, 4b squared, radical a. Please try these. I did some of your examples on the other one. You're going to do all the highlighted problems. Try those, check your answers, or let me know when you finish both pages and I'll send you the answer key. Awesome. Have a great day.